All right, so continuing on with 1.4, what we're now going to do, now that we've talked about the sense of order, left to rightness on it, now we're just going to talk about, well, what type of real numbers that we have. For starters, what we use real numbers for, right, we use real numbers to quantify reality. That's why they're called real numbers. We are constantly trying to quantify reality. You know, how many miles can I get for, you know, so many gallons of gas? How much is this meat going to cost me? You know, how much flour do I need for this recipe? How many people are in the next room? What's my score on my quiz? Well, you know, we're constantly trying to quantify reality, and hence we have numbers. It turns out that the real number system is basically broken up into two big parts. Some real numbers are called rational, and some are called irrational. So for those who are very linguistically inclined, right, IR means not. So we are either rational or we're not rational. And it gets pretty hairy about definitions wise, but it turns out that rationals contain another set called the integers that are very, very helpful for us. So let's first learn about what the integers are, and then we'll talk about all this other good stuff. So it turns out what my integers are, let's go back to my number line. What my integers are, remember when I started in the previous video, when I drew my number line, I started with 0, and then I proceeded to knock off 1, 2, 3, 4, 5, and 6. Now those numbers by themselves are called the natural numbers. But when I take those numbers and combine them with their opposites, what I have are the integers. So an easy way to visually remember what my integers are is think of the numbers you would use to scale your number line. All right, we use 0, 1, 2, 3, 4, 5, 6, and then all these natural numbers, we would look at their opposites. So technically speaking, it's the natural numbers and their opposites. But visually speaking, we're talking about all the numbers on the number line that I would use to scale it, to draw my little tick marks. Now why I went through that is here's what happens. A rational number is a number that can be written as an integer over an integer. No matter how it's presented, you eventually can write it as some integer divided by some integer. Irrational numbers, you can't do that. You can't write it as a fraction where the numerator is an integer and the denominator is an integer. And that is how we're going to talk about rational and irrational numbers, especially since I'm not giving you a calculator. All right, so we got to know what our integers are, and then if I can take my number and write it as a fraction, as an integer over an integer, it's rational. If I can't, it's irrational. And dare I say, it's that simple. So to start this homework set or this test set, how about I begin by looking at our integers first? All right, since that's kind of where it all starts. So -3, right, this is definitely a number that I would use to scale my number line. So -3 is definitely an integer. All right, let's see, 11 over 2. Well, that's a mixed number, right? That's actually 5.5. And that is, you know, that's definitely not occurring, right? It's not one of the numbers I used on my number line to scale it. So that's not an integer. The square root of 9, right? That looks pretty funky, kind of weird, but we know that the square root of 9, right? What number can you multiply to itself? Well, that would be 3. And 3 is a number that I use to scale my number line. So the square root of 9, for all its funkiness, if you would, right, still represents an integer, the integer 3. -4 over 3, well, that's technically the mixed number -1 over 1/3, and that's definitely not a number that I use to scale my number line. So this is not an integer. Pi. This is probably the most famous irrational number of them all. This is not an integer, right? It's definitely not something that I use to scale my number line. So it's not a integer. As a matter of fact, we already know it's irrational. And the square root of 17. All right, you talk about, I mean, if the square root of 9 is tough, this is even tougher, because at least the square root of 9 simplified into something nice. The square root of 17 doesn't. As a matter of fact, the closest we can get, the square root of 16, we know to be 4. So the square root of 17, right, is not a nice number. And so typically, right, since it's not a nice number, it's something that I'm probably not going to scale with my number line with, right? Because we only use the integers, the nice ones, to do that. So looking at this set of 1, 2, 3, 4, 5, 6 numbers, 2 of them, -3 and square root of 9, are integers. Now this also helps us with part A. What numbers are rational? Well, -3, I can rewrite that as -3 over 1. So I've got the integer -3 divided by the integer 1. So -3 is definitely rational, right? Because it satisfies the definition of an integer divided by an integer. 11 over 2, well, that also is an integer divided by an integer, right? 11 would eventually have been a tick mark on my number line, and 2 is clearly a tick mark on my number line. So 11 over 2 is a rational number. Square root of 9 we know is 3, and 3 can be written as 3 over 1, an integer divided by an integer. So we know the square root of 9 falls in that category. -4 thirds, well, that basically is the integer -4 divided by the integer 3, right? -4 is something I use to scale my number line, and 3 is something I use to scale my number line. So -4 thirds falls in that category. And we've already kind of addressed pi. Nowhere, well, it's on my number line, but it's not a nice, neat scale mark. And the square root of 17, right? We know the square root of 4. Square root of 16 is 4. So the square root of 17, right? Heck, we can even go further. The square root of 25 is 5. Those are the nice ones, and that's not a very nice number. As a matter of fact, it's probably really close to 4, as we'll talk about in a moment. So there's your rational numbers. So now that we've established what's rational, everything that's left is irrational. So that's pi and the square root of 17. And so there's basically a non-calculator way of being able to represent what's an integer, what's rational, and what's irrational. Putting these on a number line, again, I'd have to draw my number line out again. So somewhere on this number line is 0. And keep in mind I'm using my integers, right, to scale this number line. So -1, -2, -3, -4. -5. I'm sorry. I just think that should be enough. If we need more, we'll add more. So where's -3? Well, that one's pretty easy, right? Because that's actually an integer. So there's -3. How about I stay with the easy one? Square root of 9. Well, we know that to be 3. So there's where the square root of 9 is. So, by the way, I think I did not say this, but every real number, whether it's rational or irrational, has its own unique spot on the number line. Right? So all together, we quantify a reality, and we can see that quantification on the number line. 11 over 2. Well, on my number line, right, it might be easiest to write that as a mixed number. That's 5.5. So I'm going to come over to 5, and I'm not quite 6, but I'm kind of at that halfway point. So there would be 11 over 2, or what we otherwise know as 5.5. So far, so good. -4 over 3. Well, I've already rewritten that as -1 and 1/3. So on the negative side, I'm going to go -1, and then I'm going to cut this into thirds. And so right there, right, would be -4 thirds. So we're -1 and a third and 1/3 more going in the leftward direction. Pi, I think you guys all probably somewhere have remembered or memorized that pi is roughly 3.14. So pi, I'm going to kind of put to the right of square root of 9. And then here's the wild card, the square root of 17. Without a calculator, right, here's my best bet. I know that the closest nice number is the square root of 16, which is 4. 17 is very close to 16. So I bet you this is like 4.1-ish. So I'm going to put the square root of 17. That would be a really good estimate for it. And so there's my 1, 2, 3, 4, 5, 6 numbers that were given. There's their location on the number line. Of course, can I plot more numbers on this number line? Yes, because every real number has its unique spot on the real number line. All right, so hopefully that's some decent review of your real number system, how to order it, how to graph it, how to distinguish who's who, right? And again, for more practice, you're going to be looking at section 1.4 in my math lab. Get all this stuff back, you guys. All right, I'll see you guys in the next video.